Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0339 indicates an intermittent interruption of the CKP sensor circuit in the Honda Pilot models from 2016 to 2022. This problem is primarily associated with the crankshaft position CKP sensor, which plays a vital role in the engine's timing and operation. The CKP sensor is typically located near the base of the engine, where it can accurately determine the position of the crankshaft. It sends signals to the Engine Control Module, ECM, which translates these signals into information that dictates engine performance. If the CKP sensor malfunctions, it can lead to poor engine performance, stalling, or no start conditions. Troubleshooting DTC P0339 requires a systematic approach to identify the root cause. Proper adherence to the diagnostic procedures outlined in the repair manual is crucial for accurate diagnosis and repair. The crankshaft position CKP sensor is responsible for detecting the position and rotational speed of the crankshaft. Located at the rear of the engine block, it provides essential data to the Powertrain Control Module, PCM, which adjusts fuel delivery and ignition timing accordingly. A malfunctioning CKP sensor may prevent the engine from starting or cause it to run erratically. The PCM, or Powertrain Control Module, uses the information from the CKP sensor to manage multiple functions, including ignition timing and fuel injector pulse timing. An engine ground connection is also vital, as it ensures the CKP sensor functions correctly without electrical interference. An intermittent interruption can hinder the PCM's ability to optimize engine performance, hence the need for thorough diagnostics. Several factors can contribute to the P0339 Diagnostic Trouble Code. Firstly, poor connections in the wiring harness associated with the CKP sensor can lead to intermittent signals being sent to the PCM. Loose terminals are another common issue that can disrupt the current flow, causing the CKP sensor to fail intermittently. Additionally, a damaged CKP pulse plate can impair the sensor's ability to read the crankshaft's position accurately. Lastly, a faulty CKP sensor itself could be the culprit, failing to send the required signals to the PCM. Systematically addressing these possible causes is crucial for an accurate diagnosis and effective repair. When dealing with DTC P0339, drivers may encounter several noticeable symptoms. One of the primary symptoms is engine stalling, which occurs when the CKP sensor fails to send accurate data to the PCM. Drivers may also experience a no-start condition, wherein the engine does not crank or start at all, a serious issue that often prompts a visit to the mechanic. Erratic engine performance can manifest through rough idling, unexpected stops, or power loss. Furthermore, the check engine light will likely illuminate on the dashboard, alerting the driver that there is an issue with the vehicle's engine management system. Recognizing these symptoms promptly can aid in diagnosing the underlying issue efficiently. The first step in troubleshooting DTC P0339 involves using the Honda Diagnostic System, HDS. Start by turning the vehicle to the on mode without starting the engine. Once the vehicle is in this state, clear the fault codes stored in the system using the HDS. After clearing the codes, start the engine and let it idle for about 10 seconds. While the engine is idling, monitor the OBD status through the DTCs menu in the HDS. The goal is to determine whether the HDS shows the DTC P0339 as failed or otherwise. If it indicates failed, this suggests the failure has been duplicated, warranting further probing into the condition of the CKP sensor circuit. After the initial engine idling check, the next step is to take the vehicle for a test drive. Monitor the OBD status again during this time, focusing particularly on the DTC P0339 in the HDS. Drive the vehicle for several minutes, ensuring you operate within the recorded freeze data parameters, such as engine speed and vehicle speed. This helps ensure that the conditions under which the failure was initially observed can be replicated. If the HDS indicates failed during this monitoring, the failure is confirmed, and further troubleshooting is necessary. Conversely, if the HDS shows passed, it may suggest an intermittent failure, requiring a thorough inspection of wiring and connections. The third step focuses on checking all relevant connections associated with the CKP sensor circuit. This involves inspecting the connectors and terminals of the CKP sensor, the PCM, as well as the engine and body grounds. Poor connections or loose terminals can significantly affect the performance of the CKP sensor, leading to the intermittent issues indicated by DTC P0339. Ensure that these connections are clean, secure, and free from corrosion. If the connections are found to be inadequate, address these before proceeding. If all connections appear to be in proper condition, move on to the next troubleshooting step to examine the CKP pulse plate. In this step, the CKP sensor will need to be removed for further inspection. Once removed, visually check the CKP pulse plate for any signs of damage. The pulse plate is crucial for the CKP sensor's operation, as it interacts with the sensor to relay the position of the crankshaft. If damage is evident, the pulse plate must be replaced to restore function. If the pulse plate appears to be in good condition, the next course of action is to replace the CKP sensor itself. Failure to address either of these components can prolong the issue, so ensuring they are both in optimal condition is essential for resolving DTC P0339. Once the necessary repairs have been made, it's vital to perform a final verification to ensure that DTC P0339 has been adequately addressed. Start by using the HDS to recheck for fault codes. After clearing any codes, conduct another test drive to ensure that the vehicle operates correctly without any interruptions. Pay close attention to any previous symptoms, like stalling or difficulty starting, to see if they have been resolved. Additionally, confirm that no other diagnostic trouble codes remain in the system, as this may indicate underlying issues needing attention. Proper verification can save time and effort, ensuring the machine is fully operational and reliable. Preventive maintenance plays a vital role in avoiding issues like DTC P0339 in the future. One good practice is to regularly inspect the CKP sensor connections to ensure they are tight and corrosion-free. Keeping the electrical system well maintained will facilitate optimal communication between various components, including the CKP sensor. Furthermore, maintaining a clean and reliable engine ground is essential, as poor grounding can lead to intermittent signals and performance issues. Regular vehicle maintenance checks, which include these aspects, can significantly reduce the likelihood of unexpected engine problems. Incorporating these practices not only prevents DTC occurrence, but also contributes to prolonged vehicle reliability. In summary, understanding the importance of the CKP sensor and its role in engine management is critical for Honda Pilot owners and technicians alike. Following the structured troubleshooting steps outlined for DTC P0339 is essential for accurate diagnosis and effective repair. Identifying the root cause could involve various factors, from poor wiring connections to component failures. Equally important is the implementation of preventive measures to keep the CKP sensor and related systems in good working order. This proactive approach not only helps avert the recurrence of DTC P0339, but also ensures consistent engine performance. By prioritizing thorough diagnostics, effective repair procedures, and diligent maintenance, one can maintain the Honda Pilot's reliability and performance for the long term. Please like and subscribe to the channel. See you next time.